Hi, welcome to Nomis Academy. In this video, we are going to look at basic geometric theorems, and under it we are going to consider Theorem 3. Now, in the previous video, we were able to state and prove and also solve problems under Theorem 1 and Theorem 2. Now, in this video, we are going to state and prove the Theorem 3. Now, let's state Theorem 3. It states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other sides. Okay, so this is Theorem 3. It states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other sides. So now let's take this diagram to see clearly what we just did. Okay, this is a right angle triangle. Okay, we have something like this. This is a right angle triangle. So we can call this X, Y, Z. Okay, so with side, this is side Z, and this side is side Y. And then from here, that's from this side to this side, we call it side X. Now, based on the theorem, it says that the square of this side is equal to the sum of the squares of the other two sides. So now let's take the proof. Remember the procedure. Given what is given to us is triangle XYZ with side X, Y, and Z respectively. Okay, this is what is given to us, and now we are to prove that x square is equal to y square plus z square. So based on the theorem, we are to prove that x square is equal to y square plus z square from the diagram. Now construction. Okay, what we need to do is to draw a perpendicular from X to T. Okay, to line YZ at T. So this is what we are going to do. We draw a perpendicular, okay, from X to line ZY. So meaning that this angle here is perpendicular, and we call this T. We call that point T. So we can also state that this point from here to here is U. Y from here to here is V. Okay, so this side is U, while this side of this triangle is U. Mind you, what we have inside are two right angle triangle inside the whole complete a right angle triangle. So let's continue with the proof. The proof now, the proof proper. Now, from triangle XYZ, from triangle XYZ, that's the whole triangle, cos, let's pick Y, cos Y, cos Y is equal to, remember cos is adjacent over hypotenuse. Now this is the adjacent and this is the hypotenuse, which is Z over X. Okay, also from triangle XYT, triangle XYT, cos Y is equal to cos Y. In this case now, V is now the adjacent. This is the angle. YZ is the hypotenuse. So cos Y is equal to V over Z. So if cos Y is equal to Z over X, and cos Y again is V over Z, it means that therefore Z over X is equal to V over Z. So when you cross multiply, Z times Z is Z squared, equal to X times V is XV. Alright, so let's pick this as equation 1. So in similar way, if we do the same thing, what we just did in this small triangle, if we do the same thing here, we will also get Z square to be, sorry, not Z this time around, it's going to be Y. It's going to be Y. So we have Y square, that's the side Y. Y square will give us XU. So we take this as equation 2. Alright, so since we have equation 1 and equation 2, let's add the two equations together. Let me clean the other side of the board so we continue from there. So adding equation 1 and 2. So we add 1 and 2, that will be Y square plus Z square equal to, we are adding XU plus XV. Now Y square plus Z square is equal to, we pick what is common. X is common, and then we have U plus V. Alright, remember also in the diagram that U plus V is X, is the side X. So we have Y square plus Z square equal to X into X. Alright, in the triangle, remember, we have something like this. Which is X, and then we have here to be U, and then we also have here to be V. So U plus V is TX, so that's why we have X. So Y square plus Z square is equal to X times X is X squared. So therefore we have our X square equal to Y square plus Z square. So this is the proof. Hence you write hence proof. So thank you for watching. See you next time. Bye.